Okay, this is lesson 6.3, solving systems of equations by graphing. To solve a system of equations means that you're going to look for the point where the equations are equal. Solving graphically means you're looking for where the 2 points cross, or the point of intersection. And a point of intersection will be a coordinate x and y, and it will satisfy both of the equations. So what that means is if, for example, the solution was 1, 2, that was the point where they crossed. If you plugged in 1 to both equations for x, the answer for y would be 2. It would satisfy both equations. And that's the point where both equations are equal, and that would be the point on the graph where they cross. So we're going to try to do that by graphing two lines and seeing where they cross. So let's give it a shot. We've got y equals 3x minus 4 and y equals negative 3x plus 2. Both of these equations are in y equals mx plus b form. So we can graph both of these equations by starting at the y-intercept and using the slope to find another point. So let's give it a shot. The first one is 3x minus 4. So I'm going to start at minus 4 because that's our y-intercept. We've graphed these type of lines before. And I'm going to use my slope of 3 to find another point. Mathematically, that would be 3 over 1. So a rise 3, run 1, start at negative 4. Rise 3 would take us up to negative 1. Run 1 would be over 1. And now we have two dots. And with two dots, we can connect them to draw a straight line. We're going to continue our line across the entire graph to make sure that we can find the point of intersection, and we're going to label the equation label the line with the equation, 3x minus 4, so we know which line is which. To graph our second line, we have y equals negative 3x plus 2. That slope would be negative 3 over 1, so it would be a fall of 3, a run of 1, starting at the y-intercept 2. So starting at 2, we would go down 3, that would take us to negative 1. Over 1 takes us to this point, which was on our other line. We're going to connect the dots to form a straight line. And we're going to label it with the equation, y equals negative 3x plus 2. Notice at the end of both of my lines I put arrows to show that the lines continue forever, and I labeled them with the equation. Now the solution to this system is the point of intersection where they cross. In this graph we can see the POI, or point of intersection, is 1, negative 1. And that's the solution. The solution to this system of two equations is the point 1, negative 1. If you wanted to verify that you got the right answer, you could check. And the way you check is you plug 1, negative 1 into both equations to see if the left side equals the right side. So let's try the first equation. First equation is y equals 3x minus 4. 1 for x, 3 times 1 minus 4, negative 1 for y. Do a little bit of math. 3 times 1 is 3 minus 4 is minus 1. Left side equals right side. In our second equation, we have y equals negative 3x plus 2. The y from our point of intersection is negative 1. The x from our point of intersection is positive 1. So we've got negative 1 equals negative 3 times 1 plus 2. Negative 3 times 1 is negative 3. Plus 2 is negative 1. Left side equals right side. If the left side and the right side are equal on both, that means the point of intersection is in fact 1, negative 1. So that's our answer. Let's try another one. This time we have an equation in standard form, and we have an equation in y equals mx plus b form. Graphing in y equals mx plus b form is pretty straightforward. We've done a lot of that. So let's start by doing that one. Start at negative 2, and then use the slope to find another point. Our slope is right here, and there's no number, it's just a sign. The number in front of x would be negative 1, and as a fraction it would be over 1. So that would be down 1 over 1 to get another point. We got 2 points, we can connect the dots. And continue the line all the way across the graph. Arrows on each end. Y equals negative x minus 2. Now, graphing a line in standard form is a little bit trickier. We learned a method yesterday. That method was to find the x and y intercepts. So I'm going to do that. X intercept. I'm going to write x int. To find the x intercept, we would make y 0. So I'm going to use my equation, x minus 3y, and instead of y, I'm going to write 0. And I'm going to solve for x. That would give us x minus 0, so just x, plus the 6 that remains. So putting the 0 in for y eliminated that term, and we're just left with x plus 6. Move the 6 to the other side, and we get x equals negative 6. Which means that the x-intercept is negative 6, 0. So on our graph, for x-intercept, we got negative 6, 0. Y-intercept. To find the y-intercept, we would make x 0. So in my equation, instead of x, I'll write 0. 0 minus 3y plus 6 equals 0. Start isolating for y. I'm going to move the 6 to the other side. I get negative 6, and negative 3y stays. Divide both sides by negative 3 to isolate for y. And I get y equals 2, which means 0, 2 is the y-intercept, which is right here. Got my 2 dots. I can connect them to draw my second line. Oh, forgot to continue it the other way. And label it with the equation. X minus 3y plus 6 equals 0. And to solve this system, I need the point of intersection, so where they cross. That's my POI, where they cross, and the coordinates are negative 3, positive 1. So therefore, the POI, negative 3 for x, 1 for y. And if we did a check, we could plug in the x and the y and show that left side equals right side to verify that we're right. We won't check this one for the sake of keeping the video at a manageable length. But that's graphing a standard form and a y equals mx plus b form, finding the point of intersection. Last question. Let's look at an application. Gone ahead and labeled my graph already. If you want to take some time to do that, go ahead. Example 3 says a video rental company has 2 monthly plans. Plan A charges a flat fee of $32 for unlimited rentals. So that means no matter how much or how many videos you rent, the cost will be $32. While Plan B charges an initial fee of $8 plus $4 per video. So let's look at the cost C for the number N of videos rented. For Plan A, the cost is $32, no matter how many videos are rented. So it doesn't matter the number of videos, so there is no N term. There's no MX term if it's y equals mx plus b. It's just the cost is $32, which is like the equation y equals 32, which if we remember our special case lines, that's a horizontal line. Because no matter what the cost, no matter how many videos are rented, the cost will be $32, which means that if I were to graph that, I would have this line. Horizontal line through 32, because if you rent one video, it costs $32. If you rent 2 videos, it costs $32. If you rent 10 videos, it costs $32. It's always $32. It never goes up or down. So it stays at 32. Plan B is a little different. Plan B, the cost starts at $8 plus $4 per video. So 8 is our start plus $4 per video, and videos are N, so it's 4N. 4N, $4 per video, plus 8. How would we graph that? Well, this is y equals mx plus b form. Y equals m slope X plus B. So we're going up $4 for every video, starting at 8. 8 would be here. Up $4. Well, if we're going up by 2's on this scale, $4 would be 2 up. So we get another dot here. So it looks like it's up 2 over 1 every time. Up 2 over 1. And I keep doing that until I hit my other line. Up 2 over 1. Up 2 over 1. Up 2 over 1. At this point, we could probably just draw a line through it. I'm just going to keep doing the dots. Up 2 over 1. Up 2 over 1. And keep going all the way to the end of my graph. Why not? Up 2 over 1. Up 2 over 1. And that's about it. So I'm going to connect these dots with a ruler. And this line represents plan B. It starts at 8 and goes up $4 a video. Using the graphical model, determine the conditions under which you would choose plan A or plan B. Make sure you explain the meaning of the point of intersection. So here's the point where they cross, the POI, and the coordinates of that point are 6, 32. To explain the meaning of what this is, we have to just look at what 6 and 32 are. 6 is number of videos. So 6 videos costs $32. What's significant about that is 6 videos cost $32 for both plans, Plan B and Plan A. So 632, or 6 videos for $32 is the same for both plans. That's what's significant about the point of intersection. When would we choose each plan? Well, when we're looking to save money, we would look for what one's cheaper. Which one's cheaper would be which one's lower on the graph. So if this is plan B and this is plan A, plan B is lower until 6 videos. And then plan A is lower because plan A is always $32. Plan B becomes more than $32. So we should choose plan A for less than 6 videos. But plan B for more than 6 videos. Less than 6 videos. For 6 videos, it doesn't matter which company. So if you want to make the switch after 6 videos and switch to plan B, that's fine. Maybe there's a special promotion or something extra you get for staying with plan A. Who knows? But based on this information, 6 videos is the same for both companies. B is cheaper before 6, A is cheaper after 6. All right, that's 2 examples of graphing and solving for the point of intersection, and 1 application example. Thanks for watching, and I'll see you next time.